Welcome to the lecture series of soft computing in computer science. Today's topic is optimization algorithms and how it is going to be solved in an intelligent way. So, to introduce the algorithmic concept, let me first introduce what is an optimization. If you look at this slide, in the picture a man is walking along the road. So, if you could see that while walking along the road, the man would have 4 or 5 possibilities to reach the destination. So, what path the man will choose? Obviously, the man will choose a path with a minimum distance. Let me discuss about the second picture. If you look at the second picture, so just assume that they are all graduates and are going to get some job. So, if you look at the case, these persons are being offered with 2 to 3 jobs. Among the 2 to 3 jobs, the persons are interested to choose only one job. So, what job he will choose? He will choose a job which offers more salary. So, if you could see this two sentences, one is minimum distance, another one is maximum salary. So, these are all the keywords that are always associated with the task of optimization. Let me illustrate this in another picture. So, you look at this picture, what these persons are doing. The persons are dealing with the dealer in order to purchase a 4-wheeler. So, what might be the objective of this person? This person will always look for a vehicle whose mileage is very great. How the mileage is measured? The mileage is measured in terms of maximum number of kilometers traveled with the minimum amount of fuel consumption. So, there are two different kind of objectives are there in this optimization problem. One is maximum kilometer, another one is minimum fuel consumption. So, those two objectives are involved in this kind of optimization. Let me go further into one more examples. Look at this picture. So, what you could infer from this picture? So, in this picture shows that a girl is about to buy some materials from the online shopping. So, what might be her objective? So, her objective is to purchase a cloth which offers maximum quality and minimum cost. So, you usually call by the name cheap and best. What do you mean by cheap? The word cheap means it is always looking for the cost. So, the cost should be minimum. So, what is meant by best? The best words always refers to the word quality. So, what you always looking for a quality, it should be a maximum quality. So, here also we could see that there are two objectives involved. One is quality, another one is cost. With respect to quality, we are always looking for a maximum quality. With respect to cost, we are looking for a minimum cost. So, this is yet another example for optimization in real life. So, whatever may be the kind of optimization we could see in real life, if it is to be solved using computer, first of all that optimization has to be converted into a mathematical statement. If you look at this presentation, if you could see that, so any objective function capital F, it should be preceded by the word minimize or maximize. So, minimize or maximize F is equal to small f of x1 to xn. So, what is this small f? This small f is nothing but a function over the various collection of variables. So, what are those variables are called? These variables are called decision variables. And what is this capital F is called? This capital F is called by the name objective function or fitness function. So, what is this problem statement is saying? We have to find capital F, which is nothing but a function over a certain decision variables, and if you could find a value for a decision variable, and if that value of the decision variable finds a capital F which is either minimum value or maximum value. So, we always looking for a kind of optimum value for the capital F, provided we could find a suitable value for the decision variables x1 to xn. So, accordingly you have to coin the mathematical statement. Let me explain this scenario with one more example. Let me take an example of preparation of coffee. So, if you look at this problem statement, preparation of coffee is not a problem, but preparation of a coffee which tastes good is a problem statement. So, how to make this problem statement as an optimization problem statement? So you have to see the ingredients that are needed for preparing a coffee. So what are the ingredients needed? Milk, sugar and coffee powder, right? So in order to maximize the taste of the coffee, what we need to do? We need to mix these three components, these three variables, M plus S plus C, that is milk plus sugar plus coffee, in a right proportion, so that the coffee will give you a maximum taste. So here there are some conditions or constraint that is given, that is called border constraint. That means a range for each and every variable. Say for example, if you look at this, milk is from 25 ml to 100 ml, sugar is from 1/4 teaspoon to 1 teaspoon, coffee powder is from 1/4 teaspoon to 3/4 teaspoon. So within this allowed limit of range for a certain variable, you need to choose the right proportion for M, right proportion for S and right proportion for C. If these three variables are mixed together, then you will get a good tastier coffee, that is the T, that means a taste, the variable taste T is a maximum one. So in such a way you have to coin a optimization problem statement. So in order to proceed with the task of optimization, the first requirement is you should look for whether this kind of task or whether this kind of problem is an optimization problem or not. If it is an optimization problem, then you need to look into the possibilities of number of decision variables available in that problem, and then you need to decide about the constraints, that means the border values, range values for each and every decision variables. Then you have to frame the problem statement in a mathematical way. It's a simple arithmetic function which involves the predicate either maximize or minimize according to the desired goal, with the objective function capital F, which is equal to a decision over the set of observed variables, that is decision variables. So that way you have to coin the problem statement for a mathematical state problem. Now coming to the main picture of this today's presentation, that is what is a genetic algorithm. By the name implies, what is an algorithm? First of all, an algorithm is a step-by-step instruction to solve any problem. But if you could see the word genetic, you may wonder that how a biological word genetic can be associated with a computer word algorithm. Let me explain you one by one. Before that, you should know who is the founder of this particular algorithm. So the founder of this algorithm is John Holland. He developed this algorithm in the year 1975. So the basic idea or the basic inspiration for developing such algorithm is Darwin's evolutionary theory. So in order to mimic the Darwin's evolutionary theory with this particular algorithm, I will come to this picture in the later stage, but before that, as a computer science student, you should remember that what is an algorithm? An algorithm is a step-by-step process of executing a problem in order to find the solution. In such a way, what are the steps of this particular algorithm? If you look at the slide, so you could see that the first step while applying the algorithm, that is genetic algorithm, for any optimization problem is representation of the solution variable, and the second step is random initialization of set of possible values for the solution variable, and third step is evaluate each value of the solution variable by calculating the value of the objective function, and step 4 is selecting the best value for the objective function. The step 5 is the core and main important step of this genetic algorithm, that is creating the new possible set of possible values for the solution variable by applying certain count of operations to the existing solution variables. And the final step is repetition of the step 3 to 5 until we reach the desired goal. So if you look at the algorithmic steps, you might wonder that how this algorithmic steps will be helpful for us to solve an optimization problem. But if you try to understand this algorithmic step with a simple mathematical example, you would wonder that, so this is the best way of solving the optimization problem in a population way of methodology as well as the procedures. So let me explain the step one by one with an example. Let me check the first step, that is representation of solution variable. Dear students, what I said to you is decision variables, right? So small f over the collection of decision variables. The decision variables are represented by the letters x1, x2, x3, etc. up to xn. So likewise, the variables are also called by the name solution variable. Why is it so? Because these are all the variables which are necessary to find the solution for the entire objective of the problem, that means capital F. So this variables is otherwise called by the name solution variable. Let me take a simple function, that means maximize f of x equal to x1 plus 2x2, where x1 is in the range 0 to 3 and x2 is in the range 1 to 5. If you could see that this is the mathematical statement given to us, and our objective is to find the value of f of x which maximizes the entire quantity of the value. So how to solve this problem? You have to find the value for x1 in such a way that the value for x1 should be from 0 to 3, and you have to find value for x2 and such that you should be within 1 to 5. Accordingly, you have to find a suitable combination, and that combination of that value, if you could substitute in the objective function, you will get a desired maximum value for the given problem statement. In order to doing so, the first step, as I illustrated, is the representation. In the literature, if you could see that while solving or while applying genetic algorithm for any optimization problem, there are various representation strategies are available. The first representation strategy which is widely used and widely followed is the binary representation strategy. Followed by binary representation strategy, one can go for real number representation or integer number representation or character representation. So this presentation will give you an idea about two different kinds of representation. One is binary number, another one is integer number representation. Let me go into the next step. So this is the first step. So dear student, do you think that is it a computational step or it is a strategic step? Is it a strategic step? That is, we are going to decide a strategy, what kind of representation strategy we are going to follow, right? Out of the 4 representation strategy, you can follow any one of the representation strategy that suits the problem statement. So here in this presentation, I am going to deliver the 2 different representation strategy, binary number and real number, right? So the step 1 is over. What is the next step? If you could see the next step is random initialization of the set of possible value. Dear student, you should remember that it is not a single value, it is a set of possible values. And how this set of possible values are initialized? It is initialized in a random manner. For how many variables? Set of solution variables. So in a optimization problem, you are not given with only one solution variable. In general, you will be given with more number of solution variable. So if you could given with more number of solution variables, for all solution variables, you should give a maximum or more number of set of possible values, and all those possible values are initialized in a random manner. So in order to proceed with this step, first you should decide a capital N. So what is this capital N? This capital N is nothing but number of possible values for the solution variable. So first you have to decide how many number of possible values I am going to consider for initialization of the solution variable. Say for example, in this presentation, let me take n equal to 5. That means I am going to consider 5 different values for the variable x1 and 5 different variables for the variable x2 within the range 0 to 3 and within the range 1 to 5. So look at this, if you look at the presentation, for binary representation, I have x1 and x2 separately and that binary numbers are randomly initialized, and for real number representation, I have x1, x2 separately and the real numbers are represented. Here there should be one question. What question is, how do I decide the number of binary bits for the decision variable if I choose a binary number representation, for which assume a small n. Small n is nothing but number of binary bits that has been decided for representing the solution variable. Also it is a thumb rule, or sometimes it might be some trial and error approach also you can follow in order to initialize the solution variable. But there is some trick for finding out the number of bits that are required for representing solution variable. If you look at the range given for the solution variable, the variable x1 is within the range 0 to 3 and the variable x2 within the range 1 to 5. So with the understanding that, with an experience that, we can come to know that, or we can decide a particular idea of having 4 binary bits for deciding a solution variable. So x1 we need to initialize binary bit value in terms of 4 binary bits, and x2 in terms of binary digits, 4 binary digits, you have to decide the binary values. Since capital N is equal to 5, I have to decide the 5 different sets of binary values, both for x1 as well as for x2. So this is the second step. Students, do you think that is it a computational step? Definitely not. So like first step, this step is also not a computational step. This step is also a strategic steps, provided you should depend on 2 different values. One is capital N, another one is small n. Small n is required if you go for binary number representation. Capital N alone is sufficient if you go for real number representation, right? So first you should decide the capital N, that means number of possible values, and then you should decide the small n, that is number of binary bits for binary number representation. But for real number representation, capital N is sufficient. So for the problem that is given as an example here, capital N is equal to 5 and small n is equal to 4. Accordingly, 5 different possible values of 4-digit binary values have been chosen for the variable x1 and x2, and for real number representation, straight away we will be going to represent the variable, right? So this is the second step. Let me go to the third step. So in the third step, what you have to do is the randomly initialized set of possible values are chosen one by one, and it has to be substituted into the objective function in order to get the capital F value. If it is a real number representation, we no need to worry about anything. Straight away we have to choose the value and substitute in the objective function. Suppose if you go for a binary number representation, then you need to do a little additional task in order to fulfill the situation. So what is that additional task? See how many number of bits that we have chosen here. We have chosen about 4 binary bits. So if you choose a 4 binary bits, in general, how many possibilities are there? So 2 to the power 0 to 2 to the power that 4 binary values. That means 0 to 15 is the possible values. But what is the allowed range for x1 and x2? So x1 should be in the range 1 to 3. x2 0 to 3, sorry, 0 to 3, and x1 should be in the range 1 to 5. So this range should be mapped to the range of 0 to 15 in case of 4 binary bits. So when you choose a binary number representation for solving such kind of problem, then you need to apply a particular rule called linear mapping rule. So the formula for linear mapping rule is given here. If you could see that that number, that means the decimal value for a number x should be the minimum range value, that is you have to calculate the ratio of the maximum value minus minimum value, its equivalent decimal value divided by 2 to the power L. Here what is L? L is the number of binary bits. So if you could solve the value, see what is this value accordingly for this x1? x1 is equal to x min. What is x min? Minimum value. For this x1 range is 0 to 3. So x min is 0 plus x max. What is x max? So let me take so this is 0 x min for the case, the first case, and this x max is 3 because it is 3. So 3 minus 0, the decimal value equivalent is you have to calculate. What is 0, 1, 0, 0? This is 2 to the power 0, this is 2 to the power 1, this is 2 to the power, like that. So if you calculate this, its equivalent decimal value has been substituted, and here 2 to the power L minus 1. So L is nothing but number of bits. So if you substitute these value into this linear mapping rule, you will get this value as the equivalent decimal value. So 0, 1, 1, 0 in binary space is linearly mapped to a real number phase as a number 1.2. Accordingly, you have to calculate for all the other binary digit value. So here one should agree that if you go for binary number representation, there is a little overhead. That means there is a little burden of computing the computing the equivalent digital real number value by applying the linear mapping rule. This is what you have to do. So when you go for real number representation, you need not bother about that. So straight away you can decide that and you can substitute into that value. So student, do you think that it is an evaluation step? Yes, of course, it is a computation step. So what is the computation involved here? So out of the 3 steps that we have seen so far, the step 1 as well as the step 2, both the steps are straight away the application of the strategy, but this step you have to apply some formula in order to convert the binary equivalent value to a decimal value. But for real number, no need to apply any formula, but for binary you should apply a formula, and that formula is a very popular formula of popularly called as linear mapping formula, right. So after this third step, what is the fourth step? Fourth step is displaying the best value of the objective function. Say after substituting the each and every possible values of x1 and x2 to the objective function, finally you will get a capital F value, right. So the capital F value you will get, you will have to decide upon either it is maximum value or minimum value, that depends on the objective function. So here it is mentioned as maximum value. So you have to choose the maximum as the value for the fitness values, that is 11.46 as the first case. If you could look at the previous slide, so what is the maximum value of f of x here? For this particular combination you got 5.86, for the next combination you got 11.46, for the third combination 7.33, fourth combination 11.4, fifth combination. So out of these 5 possible 5 calculated capital F of x value, you got 11.46, that is the maximum value. So you have to choose that particular value as the best possible value at that particular iteration, right. So that is the fourth step, that is display the best value of the objective function. Now coming to the step 5, as I told already, this step 5 is the core step of this particular algorithm. So originally we start with the initial set of possible values, but in the step 5 only you are going to compute the another set of possible values, that is the random initialized set of possible value should be converted into a computed set of possible values, random possible values, computed possible values. The step 1 random possible value will be changed into a computed possible values in step 5. So how to compute the set of possible values from the random initial possible value, that's the step 5. So in order to do so, you should carry out 5 or 4 different operations in order to convert the random possible values to computed possible value. Out of that 4 operations, 3 operations plays the major role. The first operation is a simple copy operation, that is keeping the best 2 into a separate one. How do I know what is the best value? The best value is the one which gives the maximum value. The maximum value is 11.46. What is the next possible value? That is next best value, 11.4. So I have to take this 2 decision variable value in a separate one for future purpose. That is the operation 1. What is the operation 1? Process of selecting the best 2 individuals and keeping it separately, which will be used for next subsequent task. Then operation 2. So what is this operation 2? Operation 2 is giving more opportunity for good values by omitting the or by giving the less opportunity for the lesser value. If you could see in this slide, 11.4 is a better value, 11.46 is a better value, 7.93 is a better value, but 5.66 is a poor value. So while doing this operation, that is step 5 second operation, the variable which is giving good value, that is 11.46, is giving more opportunity than the worst value. So the best value has been selected and has been overwritten in the worst place, that means 5.86. So this also has to be done in a random manner. So it is selecting the best possible value and putting it to the least possible value. So that is the operation 2. Next comes to the operation 3. So the operation 3 as well as the operation 4 are the very powerful operation as far as this algorithm is concerned. What is this operation 3? The operation 3 is called by the name in GA terminology, it is called by the name crossover operation. But here, since I said that we look into an algorithmic perspective, what is this step is all about, or what is this operation is all about is you have to randomly choose 2 individuals, that is a 2 possible set of values for x1 and x2, 2 possible set of values both for x1 and x2, and you should align it in a straight face like this in the slide, and you should choose a point. That point is nothing but point at which we need to exchange the value. So according to the point, so that point is also randomly chosen. Here where is that point chosen? If you look at the slide, where the point is chosen, the point is chosen here, that is the third position, first position, second position the point is chosen. So accordingly the point is moved. So when you move this value, you get a new combination. See, 3, 3.6, you got a new combination. Here also 0.6, 4.2, you got a new combination. So accordingly you got the f of x value. Next come to the operation 4. In operation 4, what you have to do is randomly choose a particular binary digits and you have to flip the value. If it is 1, then you have to flip it into 0. If it is 0, you have to flip it into 1. So this is, in GA terminology, it is called by the name mutation. So accordingly you should do that, right. So these are all the 4 possible operations. You have to do it in order to create a new set of policy. If you see that there is a new combination is coming out, 3, 4.7. Previously this kind of combination is not there in the random initialization, but in the creation of new set of possible values, you got a new combination. So let us summarize this all these things in this here, the new set of possible values. So in the new set of possible values, if you could observe that from 11.46, that is the best value in the previous case, now I achieve 12.46 in the subsequent case. So whenever you start applying this operation as illustrated in the step 6, that is step 3, 4 and 5 should be repeatedly conducted. So at the first iteration itself, you could observe that from 11.46 as the maximum value, subsequently we got the 12.46 as the maximum value. So if you could see, or if you could do this particular operation repeatedly for about 10 iteration, for about 100 iteration, definitely your best value is keep on increasing, and the final best value should be the one that is the best value for this entire problem, and it should be displayed as the best value. So this way you should do that operation. Now come to the name, why GA has its name. The way I which called by the name solution variable in a mathematical way, it is nothing but x1 and x2, that is nothing but gene. The set of solution variables wherever I call, so that is nothing but chromosome. The set of possible values, that is this thing, right, set of possible values, this is called population. The number capital N is otherwise called by the name population size. The objective function or the fitness function that I chosen from the, it is called environment. And the 4 possible operations are we have to do, are called by the name elitism, that is selecting the best 2 individuals. Then is selection, keeping the best copy give more priority, crossover as well as mutation. And the final thing is generation, how many number of iterations they have to be carried out. So when you start reading genetic algorithm, they will use this name only, gene, chromosome, population, population size, environment, this name only. But as a computer science student, you should remember it is an algorithm and it has a step-by-step process to solve any problem. So let me summarize, there are 5 steps in this algorithm. Step 1 is random initialization of possible, a representation of solution variable. Step 2 is random initialization of set of possible values. Step 3 is evaluate each possible value. Step 4 display the best value, and step 5 is applying the 4 possible operations in order to best produce the new set of possible values that plays the core of this particular genetic algorithm. And step 6 is repetition of these 3 steps iteratively in order to find the maximum or the best possible value for the algorithm. With this, I stop the algorithmic introduction of the genetic algorithm, and the case studies and the application will follow in the subsequent lectures. Thank you.